Okay, now I want to take a look at an intersecting roof here. There's lots of detail that I can pick out of this drawing. First of all, everything is still going to be laid out from the fascia line, which is important. There's the building line 2 feet in from that, so we have a 2-foot projection on here. We weren't given the dimensions of the building. I'm going to tell you that these are 2 feet on center again. If this is stick frame, chances are way better that they're 16 inches on center, but this drawing has them for 2 feet on center. The math is still the same. So we need to know lots of stuff. So I've got it written down here. I want to know the main ridge, the minor ridge, the hips, the valleys, the main comments, the minor comments, and then we'll get into the jacks after that. So in order to figure out the length of this ridge, I need to know what the height of it is so that I can figure out how much run we have at either end here to take that overall length deducted by those 2 runs. So I can see that this is a 12-12 here, which is going to set my ridge height. So it's a 12-12, and I have 16 feet of span, so I have 8 feet of run. So 8 times 12 gives me 96. So this is 96 inches of height here. Now this is a 16-12 on the end here, my little hip end. So 96 divided by 16 is 6. So there's 6 units of run, or 6 feet here. You can even see it. This is to scale. So there's 2, 4, 6 feet. So 6 feet, and 6 feet is 12 feet off the total of 24. Leaves us with a main ridge length of 12 feet. The minor ridge sticks out here 16 feet, and then from here to here is half of that, so it's 8. I said 16, but I mean 6. That's 6, and half of 16 is 8. So 6 plus 8 is 14 feet. All right, now let's go right to these hips, because that's what we're after here. So we need to know what the run of it is, and we know that the total rise is 8 feet. Total rise is 8 feet there. This run here is 8 feet. And this run here, well, it's 6 feet because we're based on that. So 6 feet in, 8 feet across. We could draw our triangle over here too. That would be fine. It's the exact same triangle. What we're trying to do is find the hypotenuse there. That's going to be 8 feet. That's 6 feet. That's 6 feet. It all lines up pretty nicely. So I find the hypotenuse of those two. So 8 squared plus 8, 8 squared plus 6 squared, square root of that is 10. So it's 10 feet of run there. So it is 8 feet. The hips look like this. 8 feet, 10 feet. So if I figure out what the hypotenuse of that is, 8 squared plus 10 squared, and the square root of that, 12.806 feet. So I'm just going to turn that into inches. So the hips are 153.675 inches long. I'm just going to leave it at that. So that's how long that is, and that. So is this the same? Well, let's figure that out. This is 12 feet. Halfway here is 6. It's 8 feet there. Needs to be 8 feet there. There's our same triangle, same rise. These ridges meet here. Has a total run of 10 feet. So it has a total line length of that. So the valleys are exactly the same. 153.675 inches long. All right, so we know how long this is. Let's figure out how long each of these jacks are. And coincidentally, because this is 2 feet over, that's going on the same angle as this. It's a parallelogram. Whatever the length of this one is the same length of that one. 2 feet more over, the same length of that one is the same as this little jack here. So this hip jack is equal in length to that valley jack, in other words. So let's say jacks. All right, for 6 feet of run across this way, we have line length. Well, we haven't figured that out yet. So let's figure it out. So our main commons running this way on the 12-12. I did the math earlier. 12-12 is 16.97. That one's easy. So it's 16.97 for our 8 units to run. So the main commons are 135.76 inches. Minor commons are these here, and they're the same here. It's 6 feet of run there, 6 feet of run there. 16-12, 16-12, they're exactly the same. So it's 6 times my little triangle here, 6 times 20. I'll just put it in my calculator for you, because that's a tough one. It's 120 inches long. So that is 120 inches, that, those two as well. All right, so this one is based on this slope. So the jacks on the, let's call these the major jacks. All right, they're major because they're just on the 12-12 slope. So there's the slope that they'll be cut at. The cheek cuts we'd have to worry about later, but they're on the 12-12 slope. Okay, the first one is shortened off the main common. There's the main common, there's the 12 commons. Those are the 16-12s. So it's shortened off this main common here, 135.76. That is to 6 feet, as x is to 4 feet. And we'll have to do that same formula again. 135.76 is to 6, as x is to 2 for that one and that one. They're the same. 4 times 135.76 divided by 6. This one here, 90.507 inches. This one, 2 times 135.76. I put 75. $45.253 inches long. Okay, so that's that one, that one, that one, and that one. We have to do these ones on a steeper side now on a 16-12. We have 1, 2, 3. They will be equal in theoretical length to these ones. In actual length too, in fact. It's just the shortening is different here as it is here. So let's do the jacks for the minor. The 16-12. First one, or is going to be, well, they're all shortened off of our 120. So 120 is to 8 feet. Because it's 8 feet from there to there, as 6 is to x, as 4 is to x, as 2 is to x. Right? This is 8 feet, 6 feet, 4 feet, and 2 feet. So 120 is to 8, as x is to 6. All right, and x is to 4, x is to 2. Or I could do the way I demonstrated before, and calculating a common difference for this one. So it's 120 is to 8, as x is to 2. So 240 divided by 8 is 30. My common difference is 30. So my first jack is 120, subtract 30. So this one's 90 inches long. This next one is going to be 30 inches less than that. So the next one's, 60. That one's 60, and that one's 30. That's all of our rafters in there. So that one's 30 inches, that one's 60 inches, that one's 90, that one's 120. That's all there is to it.